Welcome. Today we'll learn about binary search, one of the most efficient search algorithms. Binary search has three key requirements. First, the array must be sorted. Second, it uses a divide and conquer strategy. And third, it eliminates half of the elements in each step. Linear search has a time complexity of O of n, while binary search is much faster at O of log n. For example, searching through 1 million elements. Linear search needs about 1 million steps, but binary search needs only about 20 steps. Now let's see how it works with a practical example. Let's find the number 38 in a sorted array. Here's our sorted array with 11 elements, arranged from smallest to largest. We start by placing left and right pointers at the beginning and end of the array. Step 1. We calculate the middle index, 0 plus 10, divided by 2, equals 5. 23 is less than 38, so we search the right half. We eliminate the entire left half. Move the left pointer to index 6. Step 2. We calculate the middle index, 6 plus 10, divided by 2, equals 8. 56 is greater than 38, so we search the left half. We eliminate the entire right half. Move the right pointer to index 7. Step 3. We calculate the middle index, 6 plus 7, divided by 2, equals 6. The value at index 6 is 38, which equals our target. We found it. Success! We found 38 in just 3 steps. We found the target in 3 steps. The maximum possible steps for 11 elements is 4. This gives binary search a time complexity of O log n and space complexity of O of 1. And that's binary search. By repeatedly dividing the search space in half. It's incredibly efficient for large datasets. Thank you for watching.